Okay, ladies and gentlemen, welcome to the video lesson for proofs from chapter 3. This lesson is it's covered 2 days in class. It's going to cover 5 videos here in this video series. Essentially, these 5 videos are going to show you examples of transversal proofs, that is, proofs using the corresponding angle postulate and all of the various theorems that spawn from it. So, we are going to go through 2 examples here in this first video. There'll be one example in the second video because it's going to show a longer approach. Then there'll be 2 in each of the 3 that follow that. So a total of 9 example proofs of using transversals. Okay, so like any other proof, anytime we do any proof, doesn't matter whether it's a transversal proof, an angle proof, a triangle proof, we always start the same way. And that is to restate the given. So our first step here should read, angle 2 is congruent to angle 7 because that is our given. Now, if we look at the picture, angle 2 and angle 7 have a definite vocabulary-based relationship. We have described all 4 possible combinations of alternate, consecutive, interior, and exterior angles. And 2 and 7, since they are on opposite sides of the transversal and are outside of the lines being transversed, are alternate exterior angles. So the fact that angle 2 is congruent to angle 7 is enough for us to definitively state that line M is parallel to line N by the converse of that theorem, the alternate exterior angle theorem. Which says that if a pair of alternate exterior angles is congruent, then the lines must be parallel. Now, if M is parallel to N, that means that 1 and 7 are consecutive interior angles, and the measure of angle 1 plus the measure of angle 7 must be 180 degrees by our consecutive exterior angle theorem. So essentially that's how these proofs are going to work. They're going to be one of 3 things. Either we're going to be given information and we'll have to use that information to prove another set of information in terms of angle pairs. We'll be given a set of angle pairs and asked to prove that lines are parallel, or we'll be given that lines are parallel and asked to prove information about angle pairs. Those are essentially what we're going to be doing here in these proofs. So this is a very short, very straightforward proof. This is a pretty basic transversal proof. Let's look at one that is a little bit harder. So one, it's a little bit harder because I've added an extra line to the picture. So now there are 4 lines in the picture, which has created a total of 16 numbered angles to work with. It does not, however, change the fact that this is a proof, and every proof starts the same way. That is with the givens. So in the givens, we are told that line B is parallel to line C, line N is parallel to line M. Those are our givens. So we start with the given information. Now, if those lines are parallel, what that means is that we are able to apply all of our vocabulary that we might need to our angles either direction, either this way or this way, because we've got all of our theorems and postulates for transversals will now apply across any of these 4 lines as being a transversal. So we're asked to prove that angle 1 is congruent to angle 16. Now, if we locate angle 1 and angle 16, there is no direct vocabulary word that describes the relationship between angle 1 and angle 16. So we are going to have to work our way through a third angle in order to come up with a statement that says that angle 1 is congruent to angle 16. Now, this doesn't necessarily take 4 steps. We've given 4 steps. It doesn't mean that it's going to take 4 steps to get there. So, here's what we're going to do. Because N is parallel to M, that would tell us that angle 1 must be congruent to angle 5. Okay, angle 1 must be congruent to angle 5 because those are corresponding angles, and the corresponding angle postulate tells us that if two lines are parallel, then each pair of corresponding angles must be congruent. Now, even though there's no relationship between 1 and 16, there is a relationship between 1 and 5, which we've just stated, and there is a relationship between 5 and 16. Angle 5 and angle 16 must also be congruent because they are alternate exterior angles, and the alternate exterior angle theorem says that if two lines are parallel, like B and C, then each pair of alternate exterior angles must be congruent. Now, this is enough information in itself for us to finish this proof because we have a property from earlier in the chapter. It's actually back in chapter 2. We said in section 2.8, chapter 2, section 8, that the reflexive, symmetric, and transitive properties apply to angle congruence. Look at the two congruence statements that we have in this proof. Angle 1 is congruent to angle 5. Angle 5 is congruent to angle 16. The transitive property would then state that angle 1 is congruent to angle 16. If 1 is congruent to 5 and 5 is congruent to 16, then 1 is congruent to 16. That is textbook transitive property. That does it for the second proof and for the first video. Our next video will cover only one example because it's going to show a more algebraic approach to these transversal proofs. It's worth noting that this solution that you've just watched is not by any means the only solution to this proof. In fact, what makes proofs so valuable is that there are probably 2 to 3 dozen correct proofs that you could write for this given in this proof. Okay, there's lots of ways to do it. So this is why we're going to be using this type of proof to sort of transition from fill-in-the-blank proofs to create your own proofs, because there are lots of ways to do it correctly, which means that there's lots of ways to do it, and we don't have to stress too much about doing it in a specific way. All right, so that does it for the first video. I look forward to the next video, and I hope that you find these helpful. Thank you for your time.